Hi everyone, we are from Group 6 that will present our project about Maxima and Minima, and this is our team members. Assalamualaikum everyone, my name is Nurul Fakihah binti Mahata and my number entry is 2818X7. I'm the first presenter in this group and I will present the background of the study in the introduction. The maximum is upper bound or biggest conceivable amount, while the absolute maximum of function is the greatest number that contained in the extent of limit. For example, fx equal to negative 16x to the power of 2 plus 31x plus 6 has the most extreme worth of 22 occurring x equal to 1. And the minimum is the lower bound or least possible sum, while the absolute minimum of function is the highest number in its stand and tends to the worth of limit. For instance, fx equal to 32x to the power of 2 minus 32x minus 6 has the complete list of negative 22. And the pure format is the one of the French mathematicians for finding the maxima and minima of capacities by proposed the general strategy and equality. He also made the extraordinary responsibilities to logical maths, likelihood and optics. They are the famous for Fermat's standard and Fermat's last theorem. The key concepts in introduction are the function of several variables, partial derivative, and the maxima and the minima problems. The first one is the function of two variables, which is the primary distinction is rather than planning upsides of one variable to upside to another variable. We can see the example for the function of more than two variables. Next, partial derivatives that can hold x consistent and consider how z changes as for y. And then lastly, the maxima and minima problem is the assurance of best and worst attributes. There are associated terms for components at least two factors, and the basic focus are the upsides of variables where the capacity subsidiary counterparts. The objective of this project is we know a portion of the hypothesis about maxima and minima, and we also can know how to utilize and further develop consistent consider their function given the numerical recommendation. Therefore, we also comprehend the expert the conditions and finish of maxima and minima of function fx.
Assalamualaikum, my name is Nur Izzati Atira binti Isratun, metric number 281456. I will present about the methodology part. In this section, we will discuss on how to determine the maxima and minima values. There are three steps. First, critical points. Next, second derivative test, and absolute maximum and minimum. Critical points. We use partial derivative to determine critical points for functions of two or more variables. A function may consist one or more critical points. To locate critical points, first let z equal to fxy be a function of two variables and differentiable with respect to x as f of x and respect to y as f of y. Next, let f of x equal to f of y equal to 0 to determine the values a and b for critical point ab of f function. Next, second derivative test. We can determine the local minimum, local maximum, and saddle point using the second partial derivative test. As stated in the formula, d equal to f of xx multiplied f of yy minus of f of xy squared, we can define the point a, b by following the scenario of d. First, if d bigger than 0 and f of xx bigger than 0, then ab is the local minimum. Second, if d bigger than 0 and f of xx smaller than 0, then ab is the local maximum. Third, if d smaller than 0, then f has a saddle point at ab. And lastly, if d equal to 0, then the test is inconclusive.
Assalamualaikum and salam berwarna. My name is Nur Ariana Shafira. My metric number is 281823. I will present my part, which is absolute value, maximum and minimum. An absolute value is examined in critical point and boundary point. A set is bounded if all its points can be contained within a finite radius ball or disk. We must find the critical point inside the set and calculate the corresponding critical value. The function maximum and minimum values on the set's boundary must be determined first. The largest function is minimum value. Boundary value corresponds to the absolute maximum value, and the smallest function value corresponds to the absolute point is determining in a range of x and y. By using x equal to a and x equal to b along x-axis and differential the fxy respect to y to determine the boundary point. If the fy exists, the boundary point is a0 and b0. If the fy does not exist, means that there is no boundary point along x-axis. Use y equal to c and y equal to d along y-axis and differentiable the fxy respect to x, determine the boundary point. If the fx exists, the boundary point is 0c and 0d. If the fx does not exist, there is no boundary point, y exists. Next, there are two theorems to find extreme value, which is extreme value theorem and extreme values of a function of two variables. First, extreme value theorem. A continuous function fxy on closed and bounded set D in the plane attains an absolute maximum value at some point of D and absolute minimum value at some point of D. Second, extreme values of a function of two variables theorem. Assume z equal to fxy is a differentiable function of two variables defined on a closed bounded set D. Then f will attain the absolute maximum value and the absolute minimum value, which are respectively the largest and the smallest values found among the following. First, the values of f at the critical point of f in D. Second, the values of f on the boundary of D.
Assalamualaikum warahmatullahi wabarakatuh, and hi, my name is Saiful Zain bin Saiful Masri. My number metric is 281538, and I'm going to talk about the example and analysis. There are many occasions when determining a quantity's maximum or lowest value is required, such as in business and economics. But let's talk about the business first. For example, in any manufacturing firm, profit is frequently stated as a function of unit sales. Finding the maximum value for this function is a simple technique to maximize revenues. So, there are a few functions that can be implemented in business to determine the profits, costs, and revenues. Okay, first of all, we have a cost function which can be determined from the total amount of fixed cost and total variable cost for each unit. Then we have revenue function that can be gained from the selling price times the numbers of unit sales or units sold. Last but not least, there is profit function which can be calculated by subtracting both revenue and the cost. Moving on to the example in business field. Adidas produced two kinds of soccer boots. One kind sells for 180 ringgit and the other one for 250 ringgit. The total revenue from the sale of X1,000 boots at 180 ringgit each and Y1,000 at 250 each is given by RXY equal to 180X plus 250Y. Adidas determines that the total of cost in thousands of dollars of producing X thousands of 180 boots and Y1,000 of the 250 boot is given by CXY equal to 40X power of 2 minus 60XY plus 30Y power of 2 plus 200x plus 190y minus 120. The question here is how many of each type of goods must be produced and sold in order to maximize the profit. Okay, there are a few steps here. Step 1, firstly we must state the profit function here, and then secondly we differentiate the function that we have stated and make it into different outcome, which are px, pxx, py, pyy, and last but not least pxy. Next, we must solve the system of equation by finding the critical point. We have to state that px and py equal to 0 in order to get two equations so that we can perform a simultaneous equation to find the x and y value. As we can see here, 2 and 3 is the only critical point, and also p to 3 is a candidate for maximum and minimum value. Okay, lastly, we must check to see whether p to 3 is maximum or minimum value by using the equation d equal to pxx times pyy minus pxy power of 2. We can see that d equal to 1200 and pxx to 3 equal to minus 180. Since d bigger than 0 and pxx to 3 is lower than 0, it follows that p has a relative maximum at 2, 3. So in order to maximize the profit, the company must produce and sell 2000 of the 180 ringgit boots and 3000 of the 200 ringgit boots and gain the maximum profit by 190 ringgit in thousands.
My name is Chu Jun Kai. My metric number is 278410. Okay, I would like to going to present the application in economy. Okay, in economy we have four types of input, which is physical capital, labor, land, and entrepreneurship. Okay, physical capital we use the symbol K. Okay, refer to tangible assets developed for use in the manufacturing process. This is category contains structures, machinery, computers, and other equipment. Okay, for the second is labor. Labor we use the symbol L or the contribution of skilled and unskilled workers. Okay, so for the third is land. Land we use the symbol B is in turn that refers to natural resource, raw materials, and energy resource such as oil, gas, and coal. Okay, so for the last one is entrepreneurship, we use the symbol H, which is referred to the caliber of business intelligence used to the manufacturing functions. Okay, so for the complex production functions, okay, we have the function of LK, which is equal to Y, okay, equal to A L power of alpha times K power of beta. Okay, so the Y is represent the total production output, L is labor input, K is capital input, A is total factor productivity, and the alpha and beta are the output elasticities of capital and labor respectively. Okay, so these values are contains determined by available technology. Okay, so the limit of alpha is from 0 to 1, and the limit for the beta is 0 to 1 also. Next, we go into the problem and statement in real life. Suppose the both square should have production function of perfume is given by Y is equal to L power of 0.5 times K power of 0.25. The selling price of the perfume is 10 ringgit per unit. So the cost of the capital is R, okay, which is 2 ringgit per unit, and the cost of labor is W, which is 1 ringgit per unit. Find the maximum of profits. So step 1, we should construct a profit function. Okay, the profit function is the P times the Y minus W times L and minus R times K. So the profit function we will get 10 times L power of 0.5 times the K power 0.25 minus 2K minus L. So step 2, we are going to using the first derivatives, which is the delta profit per delta label. Okay, so the final we will get 5 times the L power of negative 0.5 0.5 and k power of 0.25 minus 1. Okay, so we were going also to the capital. Okay, so the delta profit per delta capital, we will get 2.5 times L power of 0.5 times k power of negative 0.75 minus 2. Step 3, we need to find the critical point. So for the critical point, the first derivative is the equal to 0. Okay, the delta profit, the delta label is equal to the delta profit per delta capital is equal to 0. So we will get the two functions. The first function is the 5 times L power of negative 0.5 times k power of 0.25 is equal to 1. And the second function is 2.5 times the L power of 0.5 times k power of negative 0.75 is equal to 2. Then we use the first functions, the first equations divided the second equation. So we will get 2k per L is equal to 1 per 2, and then the L is equal to 4k. So we substitute back the L into the second equations. So we will get k is equal to 625 per 16. Okay, the L we will get 625 per 4. So the critical point is 625 per 4, comma 625 per 16. Okay, step 4, we going to using the second derivative test to find which is the absolute maximum or absolute minimum. Okay, so for the second derivative profit per label, we will get negative 2.5 times L power of negative 1.5 times k power of 0.25. Okay, so we will get the second derivative substitute the critical point, we will get negative 2 per 625 for the second derivative profit per label. Okay, so for the second derivative profit per capital, we will get negative 1.875 times L power of 0.5 and the k is power of negative 1.75. Okay, so we substitute the critical point into the second derivative of the profit per capital, we will get negative 34 per 625. Okay, so for the second derivative of label and capital, we will get 1.25 times L power of negative 0.5 times k power of negative 0.75. Okay, so we substitute the critical point, we'll get 4 per 625. Okay, so we need to use the D to test which is local maximum or local minimum. Okay, so the D function's formula is the second derivative of profit per label times the second derivative of profit per capital minus the second derivative per the capital and label together. Okay, so we substitute the values. Okay, from the above we will get the D is more than 0, and then we refer back to the second derivative of profit per label, we will get negative 2.625. Okay, which is less than 0, since the point is a local maximum point. So we can note that the point is the local maximum point, which is represent the maximum label and the maximum capital. Okay, so we substitute the point back into the profit functions. Okay, the profit functions is the just we construct at the step 1. Okay, so we substitute into the function 10 times L power of 0.5 times k power of 0.25 minus 2k minus L. Okay, so L we substitute 625 per 4, k we substitute the 625 per 16. So after we calculate, we will get the maximum profit is 78 per 13 ringgit. So the output is the 3.25 output. Okay, therefore the both square should have label at L equal to 625 per 4 units, and the capital is equal to 625 per 16 units to produce the maximum output of perfume 32 units to maximize the profit at 78 per 13.
So the conclusion is we can see from the report two application of partial derivative has been examined. We can see the choice of issues that embrace by recognize the situation that experience in human everyday existence, which include the economic and design need. Throw on the single variable capacity on account of maxima and minima, ensuring content streamlining the idea of utilization and works on the consistent that consider demonstrating the numerical suggestion. We also desire to explore more in further on the subject in association with the considered to be a beginning stage for guiding more significant outcomes regarding the matter. Okay, that's all from us. Thank you.